In this video lecture, we will learn about mechanism, machine and structure. We'll also try to understand the difference between these three. So let's begin the discussion with mechanism. In a given kinematic chain, if one of the link is fixed, then the arrangement can be used to transmit motion, and this arrangement is called as mechanism. Say for example, I have considered a 4-bar chain. So this is link number 1, this is link number 2, this is link number 3, and AD is link number 4. In this kinematic chain, if I will be fixing link number 1, then it is possible for link number 4 to have a complete rotary motion, and that can be transferred to oscillatory motion of link number 2 via link number 3. So this configuration is called as a mechanism. In second example, you will notice that this is link number 1 which is fixed. This is, let us say, link number 2 which is acting as a crank. This is link number 3 which is acting as a connecting rod, and the piston is acting as link number 4, while cylinder is basically a fixed link in this configuration. So it becomes link number 1. Once again, in this configuration, in this single slider chain, by fixing link number 1, the rotary motion of link number 2 is transmitted into a reciprocatory motion of link number 4, which is piston. So this configuration is called as a mechanism. Now on the screen, different practical examples of mechanisms are shown. This is example number 1, which is wiper blades of a car. This is example number 2, which is a typewriter. This is example number 3, which is a wrist watch. And here is example number 4, which is toys. Now all these are examples of mechanisms, and these practical examples are used to transmit only motion. So if in a given kinematic chain, if one of the link is fixed, then the arrangement can be used to transmit motion, and then that arrangement is called as a mechanism. Let's try to understand what do you exactly mean by machine is. Machine is basically combination of resistant bodies having a relative motion between them, and it is typically used to transmit power and motion as well. Say for example, lathe machine, milling machine, fan, mixer, car, JCB, etc. So as you can see in this practical example, which is lathe machine, it uses different resistant bodies like maybe tailstock, maybe carriage crosshead, maybe bed, maybe headstock and chuck, and all these resistant bodies are having relative motion between them, and their combination is used to transmit motion as well as power. The same discussion is applicable to second practical example, which is mixer and grinder, or this beautiful car, or this JCB, which is basically an earth moving equipment. Structure is basically combination of resistant bodies again, but there is no relative motion between those resistant bodies, and it is typically used to carry loads only. Say for example, the roof truss. Now if you look at this practical example, roof truss, it is consisting of number of resistant bodies which are welded together. So these resistant bodies are having no relative motion between them, and obviously the roof truss is used to carry only loads. The second practical example for this one is the bridge. Once again, bridge consisting of number of resistant bodies. For say for example column, maybe this beams and so on. However, there is no relative motion possible between these resistant bodies, and once again the sole purpose of bridge is to carry loads only. Now let us try to discuss the difference between the machine, the mechanism and the structure. So the first difference between all three of them is the definition itself. So for a mechanism, in a given kinematic chain, if we will be fixing any one link, then the arrangement can be used to transmit motion, and then that arrangement is called as a mechanism. Machine is basically combination of resistant bodies which are having relative motion between them, and it is typically used to transmit motion and power, while structure is combination of resistant bodies which does not have any relative motion, and it is typically used to carry loads only. So that's the first point. The second point is relative motion. Now yes, we know that relative motion between the links forming mechanism is present. Even in case of machine, different resistant bodies are having relative motion between them, but in case of structure, the combination of resistant body does not have any relative motion between them. The third one is use. Mechanism is typically used to transmit motion only. It cannot transmit any power. But machine is typically used to transmit motion and power and forces as well. However, structure is used to carry loads only. The fourth point is whether importance is given to cross-sectional dimensions or not. Now since machine is used to transmit only motion, it is not supposed to transmit power or forces, no importance is given to the cross-sectional dimensions. But in case of machine, since it has to transmit huge power along with forces, importance is given to the cross-sectional dimensions. And similarly, since structure is used to carry heavy load, importance is also given to the cross-sectional dimension in case of structure. Point number 5 is analysis. In case of mechanism, mechanism is basically analyzed as skeleton of a machine. In fact, different machine uses different types of mechanisms. The next point of differentiation is practical example. Mechanism, practical examples are wiper mechanism, toys, typewriters and wristwatch. Different examples for machines are engine, lathe machine, fan, etc. And the example for structures are roof truss, bridges, etc.